Okay, number 10. Do we know for a fact that segment PO is equal to OA? Okay, so of course we're talking about PO is this distance right here, and OA is this distance right here. So these are distances to the vertices. The answer is going to be no. Sometimes you guys just look at a picture without paying attention to what triangle center you're dealing with, and you just assume that the distances to the vertices are always the same. But that's false. That is a special property of the circumcenter. If this were the circumcenter, then yeah, the distances to the corners would be the same. But this was not the circumcenter. These are angle bisectors. Angle bisectors meet at the incenter. So this point is the incenter, not the circumcenter. And for the incenter, the equal distances are the distances to the sides. So everything that I just marked in blue, those three distances are equal. But for the incenter, the distances to the vertices do not have to be equal. So we do not know for a fact that PO is equal to OA. Okay, that's just for circumcenter, which would be perpendicular bisectors. So that's why that's a no. Okay, now look at number 11. Okay, we are given that segment SG is congruent to segment RG. Okay, so that's segment SG is this, and segment RG is this. Those segments are equal to each other. So basically that's telling us that point G here is the midpoint. Okay, based on that, I'm going to look at segment UG right now. Look at segment UG. Okay, from U to G goes like that, more or less. And I'm skipping around a little bit. Okay, so when you have the segment that goes from vertex to the midpoint, is that the angle bisector, the median, the altitude, or the perpendicular bisector when you go from a vertex to a midpoint? Okay, I'm hoping that you said median. Alright, segment UG is the median, and that's just vocabulary that you have to memorize. That's like one of the flashcards for triangle centers. The median is the one that goes from the vertex to the midpoint, so UG is the median. Okay. Now look at segment NG. In fact, let me just move this thing around. Okay, look at segment NG. Segment NG is not coming from a vertex, so that eliminates a whole bunch of things. But segment NG is still going to the midpoint, but now it is perpendicular. So, which one of these special lines is the one that has to hit the midpoint and it's always perpendicular? Well, I'm kind of giving it away by saying perpendicular instead of saying that it forms a right angle or 90 degrees or something like that. Of course, the one that's perpendicular and hitting the midpoint, that's the perpendicular bisector. Alright, bisector means cut in half, goes through the middle. So that's how I know it's not UE over here, which is also perpendicular. this is perpendicular, 90 degrees, but it's also the bisector. It's at the middle. It's cutting in half. So segment NG is going to be the perpendicular bisector. That looks like a 6. That's going to bother me. Alright, NG. Okay, and look, we mentioned the other one that's perpendicular, so let's go ahead and talk about that. Okay, let's talk about segment EU. Which one of these is the one that has to be perpendicular, but it also has to start from a vertex? Which is the one that goes from a vertex and then perpendicular to the opposite side? That's going to be the altitude. Okay, and again, this is just straight memorization. So if you're not knowing these, that means you need to run the flashcards that I made for you, and you need to just do them over and over again until you memorize these terms. Okay, so the altitude is the one that goes from a vertex, and it has to be perpendicular, just like EU. So that leaves angle bisector, okay, that we still have to do. So far I have yet to use this other information right here, the information that angle SUL is congruent to angle LUR. So let's do that now. Alright, let me move this out of the way for a second. Okay, they are talking about angle SUL, so let's construct that angle. Okay, angle SUL, more or less, is this angle right here. Okay, that I just drew in green. And so that's the first angle. Now that's supposed to be congruent to angle LUR. Okay. Angle LUR is this angle right here. Angle LUR. Alright, and I'll also make that green. So these two green angles that I just made, those are the two angles that are being mentioned here, and they are supposed to be congruent. Okay? So this angle is congruent to this angle. So with that in mind, of course the angle bisector is going to be a segment that's going to split these two angles right down the middle, or in other words, it's going to split the big angle SUR into these two congruent angles. Okay, so obviously, which segment is the angle bisector? Which segment is the one that's splitting the big angle in half? Okay, I'm hoping that you were just saying that is going to be segment LU or UL. Well, you can't really see it because maybe I should just do it again, or even just draw it. Okay, so I'm hoping you're seeing that it's this segment right here. Okay, that is the angle bisector, splitting this angle right down the middle. So that's going to be LU or UL. Okay, so that's how you do 11 through 14. Alright, number 15. In an obtuse triangle, is the circumcenter located inside, on, or outside of the triangle. Now there's a certain amount of memorization that you could have done for this, but if you try to memorize it, I think you're just going to forget. So what I really recommend that you do is just draw a quick picture of it. So here's an obtuse triangle. The circumcenter, when you see the word circumcenter, if you have mastered your vocabulary with the flashcards like you're supposed to, then what are the lines that intersect to form the circumcenter? Okay, hopefully you were thinking, well, that's the perpendicular bisectors. So that's what we're going to draw. So obviously, if you don't know that a circumcenter is a perpendicular bisector, you wouldn't be able to do this. So make sure you memorize your vocabulary. Oh, and of course, you have to know what a perpendicular bisector really is. Perpendicular bisector is the one that has to be at the midpoint, and it has to be perpendicular. So I'm estimating that this is about the midpoint. So if I'm going to go ahead and try to draw a line that's perpendicular to this as best I can, I'm just estimating, but that would seem about right to me. All right, I'm going to stretch these out a little bit so it's more clear. Let's see, let's make these green today. So this would be an example of a perpendicular bisector. Okay, see it's perpendicular, and I'm trying to make it so that these are congruent, so that's a bisector. So there's one perpendicular bisector. Let's make another perpendicular bisector, and that will show us if it is inside, on, or outside the triangle where they meet. So let's do this side, for example. So this would be about the midpoint of this side, you know what I mean? Because about like that. So I need another perpendicular, so let's do that. So perpendicular to this would be like one of these. That's too far. Okay, so as you can see, all right, I've got my two perpendicular bisectors. Again, that's perpendicular and it's a bisector. But the spot where they meet is here. So this would be the circumcenter. And it is clearly outside the triangle. So we will say outside for that one. Okay, let's do the next one. In an acute triangle, is the centroid located inside, on, or outside the triangle? So there's two key words there, acute triangle and centroid. All right. Hopefully you knew that an obtuse triangle was one where you had an angle that was bigger than 90 degrees. An acute triangle will be one where all the angles are less than 90 degrees. So let me draw a quick acute triangle, like just something like this. Okay, so there's an acute triangle. Make a little bigger. Now, centroid. You have to know what a centroid is. Centroid, the definition is it's where the medians meet. So your thought process is, okay, centroid, that's medians. Okay, and medians, that's the one that goes from a vertex to a midpoint. Okay, so let's do a bunch of medians. So, so here's a midpoint, and here's a midpoint, and here's a midpoint, just estimating. So if I draw some medians right now, so okay, so vertex to a midpoint, vertex to a midpoint. Okay, I can already see that these are meeting inside the triangle. Okay, inside. So this would be the centroid right here. Okay, and it is clearly inside this acute triangle. I could do a third one, and it should meet at the same spot. But you really two will do it. One more. In a right triangle, the orthocenter is located, blah, blah, blah. Okay, so let's get a right triangle going. Here's my right triangle. Okay. So there's my right triangle. This is 90 degrees. Now, this is supposed to be the orthocenter. So, orthocenter, that's altitudes. And altitudes go from a vertex, but then they have to be perpendicular. Vertex to perpendicular. So, for example, here would be an altitude. The easiest one for me to draw is the one from a vertex, and then it's got to be perpendicular. Okay, it's going to be somewhere about like that, more or less. Okay, there's my vertex to a perpendicular. So I'm shooting for perpendicular, so I'm hoping that this is perpendicular right here. So that green line would be an example of an altitude of this triangle. But we need at least one more altitude. Okay, so I've done this vertex and then perpendicular. Now I'm going to do this vertex. Okay, I'm going to switch to blue. If I do this vertex, so I need to go from this vertex and I need to be perpendicular to the opposite side. Okay, well this one's interesting because if I start at this vertex and like if I was over here, I wouldn't be perpendicular. To be perpendicular, it has to be straight up and down to be perpendicular. So it would have to be this blue line right here. Okay, the blue line I just drew is the altitude that comes from this vertex. Okay, because it comes from the vertex, and then it is perpendicular. Okay, so the blue line and the green line are both altitudes. And can you see that they both meet right here? So this point right here at the corner, that is my orthocenter. Okay, and it is on the triangle. It's right at the corner. All right, so to me, the best way to figure out if these things are inside, outside, or on the triangle is to draw them. Draw the triangle, draw the intersecting lines, and see if they're inside, outside, or on the triangle. But for that to work, you have to know your vocabulary. You have to know that an orthocenter is altitudes, centroid is medians. You have to know that a circumcenter is perpendicular bisectors. And we didn't do this one, but incenter is angle bisectors. And you have to know what those lines look like and how to draw them. Anyway, let's move on. Number 18. The main thing I told you about ones like this, to know if this point Q is on the angle bisector. In other words, if I drew another segment in here, okay, if I drew this segment like this, the question is that an angle bisector or not? But here's the main thing that you need to know. If the distances are not perpendicular, they tell us nothing. One more time. To have any information at all, these distances have to be perpendicular. If they are not perpendicular, the distances don't tell us anything. So that's why for number 18, is this on the angle bisector? Yes, no, or unknown. For number 18, we have to say unknown. These distances are marked the same, but they are not perpendicular distances. If I don't have to be perpendicular, from this same point to this same line, I can have all kinds of different distances. Okay? There's only one perpendicular distance, but there are many, many non-perpendicular distances. So non-perpendicular distances don't tell me anything. I can draw those any way I want to. So they don't tell me whether it's in the middle or not, really. So that's unknown. These are perpendicular distances, so I will be able to judge. So for number 19, I will be able to say definitely yes. If I were to draw a line here, that would be the angle bisector, because these distances, the perpendicular distances, are equal. This one is definitely, for a fact, not on the perpendicular bisector, because the perpendicular distances are not the same. So it's closer to the one line than it is to the other. So that's how you do 18, 19, and 20. Okay. Again, it all comes back to the vocabulary for this last problem. If you look at these houses, they form a triangle. Okay? Now, one of these points of concurrency, one of these triangle centers, has the special property that is equidistant. It is equidistant from the vertices. Okay, and one of these triangle centers has the special property that is equidistant from the sides. But if you want your meeting place to be the same distance from each person's house, are we talking about equidistant from the vertices, or are we talking about equidistant from the sides? Well, yeah, I'm hoping you're seeing that the houses are the vertices. So we need the one that has the special property of being equidistant to the vertices. Okay? So we need the one that works this way, equidistant to the vertices. So which one is that? All right, if you did not say circumcenter, then you have not memorized your cards, your straight vocabulary. So you need to go to your flashcards and just study them over and over again until you can automatically know, oh, circumcenter, yeah, that's the one that's equidistant from the vertices. By the way, which is the one that is equidistant to the sides? That would be incenter. So if you put centroid or orthocenter, you just were like not even close. Okay, so for this one, it would be a circumcenter. Now, so that's really the end of this homework assignment. But I just want to add this one thing on. What if instead of saying that we wanted the meeting place to be equidistant, to the houses? Let's say that each one of these houses is connected by a road. Okay, so this is a road, and this is a road. I'm spelling road wrong. And this is a road. Okay, so there are 3 roads. If instead of the vertices, if we had wanted our meeting place to be equally distant to the roads, then which one of these triangle centers would we have used to be equidistant to the roads? Okay, I hope you said incenter, because the roads are the sides of the triangle in this case. So the incenter is the one that has the special property of being equally distant to the sides. So on a test or something, sometimes I will be asking you about what turns out to be the vertices of the triangle. If those are going to be equidistant, circumcenter. But sometimes I will ask you about things like roads, the distance between, and equally distant from the sides, that's incenter. Study your cards, people. Study your flashcards. Alright, so we are definitely done with the homework, but let's do a quick study session of the flashcards right now, as long as you're here. Let's practice. So, look at this picture. I want to know what this is a picture of. I'm talking about this pink line, okay? And here are some choices. Is this a median? Is this an angle bisector? Is this an altitude? Is this the perpendicular bisector? Which one of those things is this? Hopefully you said that this is the perpendicular bisector. Okay? Because it is perpendicular, obviously, and it is cutting this side in half. This is a perpendicular bisector. Okay? What is this a picture of? Did you say angle bisector? I hope you did. It is splitting this angle in half, so this is an angle bisector. What's this a picture of? This is the median. Median. A median goes from a vertex to a midpoint. Okay? And you can tell it's the midpoint, so this is the median. What is this a picture of? This is an altitude. An altitude goes from a vertex, and it has to be perpendicular to the opposite side. Okay? So make sure you know those words. Okay, so what is the definition of circumcenter? In other words, what are the intersecting lines that form this point of concurrency? Hopefully you said perpendicular bisectors. All right? Circumcenter is the intersection of perpendicular bisectors. What's the definition of incenter? That's the intersection of angle bisectors. What's the definition of centroid? That's the intersection of medians. What's the definition of orthocenter? That's the intersection of altitudes. Okay, now let's talk special properties. Remember, some things are equidistant from the sides. Some things are equidistant from the vertices. One of them had the special properties with those little formulas with the big piece and small piece, and the big piece is 2/3 of the whole thing, and the small piece is 1/3, and the big piece is double the small piece. That was the special properties for one of them. So what's the special property of the circumcenter? This is the one that's equidistant from the vertices. Okay, the circumcenter will be equally distant to the corners of the triangle. What's the special property of the incenter? And this is the one that is equidistant from the sides of the triangle. Equally distant to the sides. What is the special property of the centroid? That's the one where we could divide it into 3 equal parts. And when I say it, I'm talking about the median. The median gets divided into a big piece and a small piece. And the big piece is double the small piece, and the big piece is 2/3 of the whole thing, and the small piece is 1/3 of the whole thing. This is a special property of the centroid. The centroid is also the center of gravity, so you should know that too. Okay, picture in your mind what a perpendicular bisector looks like. Perpendicular bisector. Remember, perpendicular bisector, it's got to be perpendicular and it's got to cut the side in half. So this is a perpendicular bisector. What is an angle bisector? It splits the angle in half. It does not have to touch the midpoint. It just splits the angle in half. What is a median? Median goes from like what to what? A median looks like this. Median goes from a vertex to a midpoint. Vertex to a midpoint. That's a median. What is an altitude? An altitude goes from what to what? An altitude starts off at the vertex, but then the other side has to be perpendicular. Alright, so it goes from vertex to perpendicular. Alright, that's it for the flashcards. If you were getting a bunch of those wrong, or if you're really getting any of those wrong, then you need to repeat that over and over again until you can get them right 100% of the time.